All right. All right, so the session is now being recorded. Okay, this is not on the exam, what I'm doing now. Okay, everything after section 2.4 is not on there. Okay, so in other words, chapter 3 is not on the exam, the second exam, that is. Let me get started with this. So basically here, as you can see, what we're doing here is I'm just pointing out what we did last time. Last time, we saw the division algorithm for polynomials. You know, just like there is a way to divide one integer by another, you can do the same thing with polynomials. And namely, what we're saying here is, if you have a polynomial f of x, okay, and you're dividing it by a polynomial d of x. So in other words, we want to calculate this. We're dividing. F, remember, capital F that is called the dividend. D is the divisor. What this is saying is there are two unique polynomials, Q and R, which is the quotient and remainder, so that this happens. In other words, if you take one polynomial, capital F, and divide it by D, capital D that is, you will get a quotient and a remainder. But you can write everything this way, which is equivalent to doing this. You know, you just multiply everything by capital D, both sides that is. And the remainder also it's either of degree 1 less than the degree of D. Oh, wait, sorry, that's not right. Let me back up. The degree of R, the remainder, is less than the degree of D. It doesn't have to be 1 less. It could be any amount less. But it has to be either 0. Capital R of X is either 0, or its degree is less than the degree of D, the divisor. Okay. And now for synthetic division, we're basically focusing on this case. When your D of X here looks like this. And since this is degree 1, as you can see, this is degree 1, this tells us that if we applied the division algorithm with synthetic division, capital R of X, the remainder, it's either degree 0 or it is 0. So in this case, we actually get capital R of X is a non-zero constant. And now last time I did present the remainder theorem, so I'm not going to write it again, although I probably could have, but I guess it's all right. It's in the notes anyway, which I did email last time. We do have the remainder and a factor theorem. The factor theorem I put here, and that just says a polynomial has x minus a as a factor exactly when f maps a to 0. This is one of the theorems I did last time. Another one is the remainder theorem. You can actually get, I know here it's capital F and the other slide it's little f. But again, it's just notation. But when you have d of x equal to this, your remainder, you can actually figure out what it is. It turns out to be f of a. That's what the remainder theorem is. It's really just an immediate consequence of this. And in fact, that tells you x minus a is a factor if and only if the remainder is 0, but that's if and only if f of a is 0. I hope the notation is not confusing anyone. I probably should have kept it as capital F here, but I mean, it's pretty much the same idea. That's what we did last time. So what I want to do now is do another example. Then we'll see something else. Basically, what we're going to see, let me go back again to the slide. We'll see what happens if instead of d of x being x minus a, we're going to see what happens if d of x is a times x minus b. I mean, there is a little bit of a manipulation you have to do. It's not terrible, but we'll see how to handle that. So for instance, let's say f of x was this polynomial. I did go through the process of synthetic division as well. This I'm throwing in here, it's just the factor theorem. We want to know, is x minus 3 a factor of this? Well, f of 3, if you calculate that, you actually do get 0 by direct calculation. That's what I'm doing. I'm replacing x by 0. So f of 3 is 0. So by the factor theorem, x minus 3 is a factor of this. So because it's a factor, if we take this and divide it by x minus 3, we should get a remainder of 0. That's cool. And that's actually what happens. That's synthetic division. I'll go through that. That is what happens here. And now you might be thinking, wait a minute, why is he even dividing it if we know the remainder is 0? Well, if we wanted to find the other factors, we would have to divide. You know, it's just like with integers. If you want to know what the other factors are, you have to divide. And here I'm just going through synthetic division. Remember, what you do is this. The number here, it has to be x minus a number. This number goes here. Okay? If this was x plus 3, we would then have we would have a minus 3 here. If this was x plus 3, we would think of that as x minus negative 3. And negative 3 would go here. It's x minus 3, so 3 goes here. So here we get x cubed minus x squared minus 14x plus 24. The coefficients we list like so. I also said this last time. If there was a missing term, that is a missing power of x less than the degree of f here, which is 3, if there was a missing power of x, we would use 0 as a placeholder. Kind of like what we did for addition and subtraction when we added or subtracted vertically. So from here, right, the first coefficient, which is 1, I bring down. Then let me get some drawing in. I can get to the pen. Oh boy. Right, from here, you're going to multiply. This came straight down because there's nothing here, so we just bring it down. 3 times 1 is 3. That product goes here. Then we add. So negative 1 plus 3 is 2. And that goes here. And then you repeat the process. So what's going to happen now? Let me erase a bit. What happens next is you do 3 times this 2, and that product, which is 6, goes up here. And basically you're going to keep on doing this until you get to the last column. And so what's going to happen is you get negative 14 plus 6, that's negative 8. Okay, one more step. So we have 3 times negative 8, which is negative 24. And so 24 plus negative 24 is 0. Right? So again, this came down. 3 times 1 is 3. We add to get 2. 3 times 2 is 6. We add negative 14 and 6 to get negative 8. 3 times negative 8, negative 24. 24 negative 24 is 0. The wonderful 0. And remember, what happened next is these coefficients here, these were the coefficients, that is, of the quotient, which is always 1 degree less than the dividend, which is f. So the quotient here would be of degree 2, and its coefficients would be 1, 2, negative 8. That's what we have here. This is our quotient. X squared plus 2x minus 8. This is the remainder term. The last entry here, that's the remainder. So now, by the division algorithm, right, this was our f. Let me see if I can write it out with the pen. This might be easier. We have our f of x, right? This is our d, capital D, that is. Capital wonderful D times q, right? This is our quotient, which is fun. And again, normally we do have a remainder term here. I mean, in this case, the remainder is just 0. But that's normally what would happen here. So yes, it is a factor. Not only that, we know it's a factor, right? I mean, this did not tell us what the quotient is, but we now know what the quotient is. If you look at this, You should be thinking, we can factor that. And that's what I'm going to do. This you can factor, right? This is something we did earlier in the course. We have x squared plus 2x minus 8, okay? X squared plus 2x minus 8. Well, this is degree 2. It's a trinomial. The leading coefficient's 1. We're basically using that AC method, well, almost I should say. From here, we get two numbers whose product is minus 8. The sum has to be 2. But two numbers that do that is 4 and negative 2. So we have minus 8 is 4. Let me actually write it out in pen. Hold on. 1 second. Let me just stop the recording.